This is the second lecture in our course dedicated to challenges or problems of object-oriented programming. So we're going to discuss static things, static methods, static attributes, and in the end we will take a look at the real Apache library, and not Apache. Sorry, this library is not in the Apache family, but we'll take a look at the open source library and criticize what they do there from the perspective which we discussed in the first part of the lecture. As you remember, in the beginning, in the first lecture, I told you that there are a number of things which make object-oriented programming not as elegant, not as effective, not as beautiful as it can be. And we're going to get rid of those things. One of these things, the first one, maybe the most important, is the static flavor which people add to many programming languages. The static methods, they exist in Java, they exist in C++, in Python, in Ruby. I don't know actually a language where such a thing would not exist, object-oriented language. So they always try to put something static, and we will see what I mean by the static. Again, the lecture is split into three parts. First, we discuss static methods, then we discuss static attributes, and then we go for the example. So we'll go through the code written by other people, and I will piss on that code and criticize it as much as I can. So first, the methods. So what static methods are for? So if you look at the two examples, two pieces of code. On the left side, you see the code with the static method. On the right side, without the static method. I'm sure you are already good enough programmers to understand both pieces of the code, so you know what is a static method. So we're not discussing in this course how to write object-oriented software. We assume that you guys already understand how to write, for example, Java code, but now we discuss how to do it better. So I will not explain you the elementary things about the code, just assume that you understand it. So on the left part, you see geometry utils. This geometry utils has a method calc_square, which expects a circle, expects an object of type circle to come in, and then it calculates the square of the circle. The example is super primitive. How does it calculate? It just takes the radius, so it takes the public attribute from the circle, and then takes it again, multiplied by p and by pi, and then return the result. There could be many things like this, the utils, the static methods. They are just staying in some global space. So this method's calc square is available for everywhere in the program. So we can easily, if that would be, for example, C language, we can just take this method and move it outside and put it here and call it just global function. So this geometry utils in Java is actually more like a namespace. So it's not really a class. It's not really, because we don't make an object from that. So we don't make an instance of this geometry utils. It's just a namespace. It's just a holder of the holder of procedures. And this is one of the procedures. And there could be many of that inside this geometry utils, many procedures there. And people put them there because they don't know where to put them. So basically, the static method, these utility classes, they are usually aggregators of global procedures, of procedures which otherwise would be globally available. And they make procedures for managing files, for managing streams, for managing, like in here, geometry things, for managing mathematical operations. Like in Java, we have this class which is called mass. So in the mass class, or which is not really a class but a namespace, you can call, for example, the function sin. For the sin function is the sinus, in order to calculate the sinus of an angle. And this mass is actually not a class but like a namespace. But still, people call them classes. So they're not calling them namespaces because in Java there are no namespaces. And in many other languages, there are no things like namespaces. But in Ruby, for example, we have modules. which are namespaces, and there people just define global functions. So I'm here talking about not only static methods, but in general global functions and global variables. So static methods, global functions, global attributes, global variables, static attributes, they're all the same. It's all the same category of creatures, and they are all bad things. Why? I'll explain you later. But now just understand what I'm talking about. The alternative implementation without the static method is here. So here we have a class circle. It encapsulates the radius. You see, that's a mistake. It should be private, not public. So now it's private, so nobody can accept that. And then we call the method square, and the square calculates the result and returns the result out. So now we're not allowing anybody to take away the radius and do the calculations outside. We just encapsulate everything inside the circle, the functionality and the data. And this is the data, or like we discussed before, the state or the data, which is encapsulated in the object. And this is the behavior. So this is behavior, and this is the state. And they're all inside an object. And the object does everything it's supposed to do without letting anybody outside of it to have any functionality. Because look at this. This functionality of calculating the square actually stays away from the class circle. So if you look at this circle, you will not understand that the circle actually can have a square. Like if they stay, of course, next to each other, then you can see that. But if you split them, if you move to different places, then you're not going to see that. And like here, you read, there's many examples of these things which exist in Java. So this is what static methods are for, to put the functionality which you don't know where to put it somewhere and call it somehow. So in my opinion, this is basically what lazy programmers do who don't have enough time or creativity or skills to think where to put the functionality, where to put the behavior, how to design the object properly. They just say, okay, I don't know, so I will make a utils class, I will make the place where everything will stay, and just put the functionality there. So what's specifically wrong with utils? I define 3 things which are wrong with these utility classes, with the collections of static methods. First, these static methods, not only utils, but in general static methods, they are unbreakable dependencies. I'll explain you now what it means. Unbreakable in a few words means that these 2 classes, like the one who is calling these geometry utils and the geometry utils, they're connected to each other. You cannot break it during the testing. I'll show you now. Second, they are eager and not lazy. There are 2 approaches to programming, which one is called eager, which one is called lazy evaluation, and another is eager evaluation. Lazy evaluation is that when we evaluate things as we're being as lazy as possible, evaluating the result only when it's really necessary. Eager evaluation means that we evaluate it right now. So I'll show you the example now. And the problem number 3 is that utility classes are not cohesive. Probably you've heard about this word, cohesiveness. There are 2 basically fundamental properties of any software code, coupling and cohesion, especially in object-oriented programming. Maybe if you don't know, there's a coupling and coupling and cohesion. So coupling has to be tight. The coupling has to be loose. Weak coupling or loose. I don't know. Maybe weak coupling. Yeah, maybe loose is the right word here. And cohesion has to be high cohesion or tight cohesion. So they are quite the opposite, 2 opposite to each other. Not the opposite, but they are orthogonal, I would say. So they're not opposite, but coupling means that one class and then another class, so they know too much about each other, like in a couple, a wife and a husband. So they know about each other too much, and they're coupled so much that we cannot break them. We cannot just say to this class, the class number 1, this number 2, we cannot say to the class number 1, just don't use class number 2, use number 3 instead. So breaking this dependency is very hard. because class number 1 already married to the class number 2. So they are so much close together that we cannot, during testing, we cannot say, hey, for a moment, just forget about this one and please work with this one, which is, for example, a mock, which is a fake implementation, which is something which we want you to use right now temporarily. We can't do that. That is called unbreakable dependency, because the coupling between them is very, so this unbreakable dependency is related to this problem. It's too much coupling between them. But cohesion is about something else. Cohesion means that if you have some class, some block of code, some module, some class, and then inside this class you have some elements which are related to the class. For example, this is the class and this is the methods. Method 1, method 2, method 3, method 4, method 5, method 6. 6 methods in the class. So cohesion means that they all need each other. So they all are somehow related to each other. So for example, this class is called circle. And then the methods are calculate the square, calculate the perimeter, move the circle, paint the circle. But there will be no method which is called, for example, a save, a delete, let's say, all these methods were about the circle, and then we have a method which is called delete file. So in this case, if we put delete file into the class circle, there will be obviously a low cohesion between them. So this method will stay here like a very strange element in the class. It doesn't belong there. So if it doesn't belong there, it means the cohesion is low. So they're not cohesive enough. So cohesion must be high. So, and the utility classes, they're not cohesive enough. They're not cohesive. The cohesion is low. I'll explain you now by example. So let's go start with the unbreakable dependencies. So this is the point number 1, which I mentioned. Point number 1, they're unbreakable dependencies, or coupling is very tight. So they are, remember the picture, husband and wife, they're too much together. So look at the code on the left. So on the code on the left, we have the function or method paintIt. The paintIt accepts the circle. So we come to paintIt and say, please paint the circle. What it does, it goes to geometry util and calculate the square first. So it calculates, okay, how much paint do I need? So there is an obvious connection between the method paintIt and the geometry utils. Right? So they are connected to each other. So paintIt really needs geometry utils. Right? So you call paintIt and paintIt goes to geometry utils, calculates how much paint it needs, then does some other operations. On the right code, which you see, their paint is also connected to the circle. So now on the right picture, we have paintIt and we have circle. And they are also connected to each other. However, this dependency is unbreakable. So during let's say you're making the test for this function, for paintIt, and you want to test whether it works correctly. You make automatic test, unit test. In order to make a unit test, you need to call this method, this method paintIt, with some argument. And you give this an argument, and you want to test how this method will react to the argument. But you don't want to give a real circle there, because let's say, like in this text, like the text says here, so let's say we want to calculate, we write a test for this block of code, which s is expected to be 42. So we want this result coming out of there to be number 42. And then 42 must be multiplied by something and then continue. With the left example, you will not be able to write such a test, because this function calc square will always be called. So no matter how you try, I mean, with the normal programming practices, then you still need to provide some circle with some radius inside, and then let this connection to do what it does. So you're gonna let this function, this one, to connect this one, get the result back, and then continue the testing. But there will never be 42 coming back from there, no matter what you provide there, because it's not going to be possible to invent such a circle with such a radius so that the square of it will be 42. It will be 42 around something with some, but not dot zero. I'm just making this example it's quite a simplified case, but to give you an understanding that it's not going to be possible to break the dependency because they will always call each other, and it's not during the testing, it's not changeable. But here it's possible. On this example, you can create your own implementation of the circle class. So let's say in a good programming, object-oriented circle is going to be an interface. In Java, for example, it's not going to be a class, it's going to be interface here as well. Interface and interface. And since it's an interface, so you will be able to create your own so-called mock or fake or I don't know, stub, there are many different words, implementation of this interface. And you give it there and you say, you know, when the square is called, don't do the calculation. Don't do the multiplication of the radius, whatever. There is no radius. My fake implementation of this circle will return just number 42. And then you can test the way you want it. So you break this dependency. The painted will not call the real circle. It will call your fake implementation of it. In this case, it's not possible. On the left example, it will always call the function, the static method. Okay, so let me read the questions you're asking. The question is, what if one wants to have different methods for squaring? It's not even the strategy pattern. Well, that's exactly what I'm talking about. So if you want to have your own implementation for the square, then you just do it and then you're fine. It's not clear how, it's not clear here why I'm reading the question. It's not clear why here it cannot be called painter utils. You pass the circle as a parameter, but you can do something like circle paint. How to know when it's okay to send parameters to the methods? It's a different question outside of this discussion, but painter utils or geometry utils, it doesn't matter. As long as you have a static method, you have a problem. Because a static method is, imagine again, it doesn't belong to the class, it just belongs to the global scope of vision. It's something which is visible from everywhere, and imagine it's a global function. And everybody who connects to this global function from all the places in the code, they call this function and they will call this function always. This dependency is unbreakable. So you will not be able to tell this code anyhow, stop calling this global function. No matter how you try, no matter how you design your tests, this connection is forever. And that's a problem. This tight coupling is a problem. So actually the problem is defined like this. This is the definition of the problem. Tight coupling. That two blocks are tightly coupled. And because of this, we have a serious problem of decoupling them. And if your code is coupled, if all your modules are coupled together and they know too much about each other and they call each other knowing exactly where to go without these interfaces, without so-called dynamic dispatch. Dynamic dispatch is done in runtime. The decision is made in runtime. So the code, when it's being compiled, the code doesn't know exactly where it's going to go. So it doesn't know where the execution will go. It is called dynamic dispatch. It's one of the key dynamic dispatch. It's one of the key qualities of object-oriented programming. We must have dynamic dispatch in order to have a good object-oriented language. So dynamic dispatch means this. So this is dynamic dispatch. You say c.square. Where do I go? In which particular block of code? We don't know. When we compile this code, we don't know. Only when we run this code, at this point of time, we will know. Now we go to this circle, and then the square is there. In another runtime execution, it could be another circle, it could be a fake circle, another class, another another object, maybe a child of the circle class or whatever. But that's going to be dynamically, the decision will be made in runtime. That's why I call dynamic. But here the decision is made statically. So the compiler, when it compiles the code, it just makes this decision. Oh, I know where is the calc square function is. It's right there. So it's a direct link. So it's going to be compiled into the machine instruction jump. Just go to, just jump directly. So this is faster. Definitely. This is slower. Definitely. But for the design, the snippet on the right is better. For performance, the left one is better. So you have to choose which one is more important for you. The beauty of your code, the maintainability of the code, the quality of the code, or the performance. Sometimes we need to do static methods, but they have to be exceptions. They have to be sometimes, not always. Okay, enough about this typed coupling. The problem number 2, they're the imperative, not declarative. So I said before, they're not lazy, they're eager. So this is, I would say, lazy, and this is imperative, is eager. Eager means they want to happen it now. And look at the code on the left, the code on the right. Again, the same example, painted, so the circle comes in, then we call the static method, and then we do if something is whatever, then we return. So we check some condition and we say, you know what, I decide not to paint it, maybe because of some situation, and we return. And then if t is false, then we continue and do the painting actually here, and we use this p and whatever. So this is eager calculation. So we calculated this, we return the s from there, even though we don't need it. So actually s is needed here, but we calculated it, and let's say we return from the code from on the line, on the third line, we jump out of the method, but we still did the calculation. That was a waste of time. That was a waste of computing resources. So we did the calculation, which was not necessary. In the second example, it's different. So look, what's happening now? Now we're not making c dot square, we're making an object here. So this is another alternative to static methods. Static methods are eager. This making new objects is more like a functional approach. You may see that in functional programming, where you take the argument and then the result which you expect to calculate, to get, you just represent as a function around this argument. And this function, you pass it somewhere. So the function so the function becomes an argument, the function becomes a so-called first-class citizen. So you have variables, you have data and a function, and you take the data, you wrap it into a function, and then pass this function to the block of code which expects that. And then they deal with this function. They take it, they may store it, and then when it's necessary, they call it. But when it's going to happen, only they decide. The same here. So we make a square of, and then we check the t, and then if the t is nothing, I mean the t is true, then we just jump out. We never do any calculations, because this new square of only lazily, I would say it lazily, prepares the calculation, but doesn't do the calculation. It's just a wrapper, it's just a box with a circle inside, ready to do the calculation. And then when it's time, we do this, and when the multiplication happens, then the calculation happens as well. Of course, this is not going to work in Java, because in Java not everything is an object. So in Java this is the data primitive, but if you use more object-oriented languages like Ruby, for example, then, or Smalltalk, then definitely this code will start making sense. So you're asking what is t in this snippet? It doesn't matter. T is something. Let's say it's some condition. It's not important. Just some condition. Okay, I didn't understand the second question, but that's my understanding of imperative versus declarative, more or less. So declarative, you are not in a declarative approach, which is this. So this is declarative approach, this is imperative. Declarative approach, you declare your intent. You say, I have a circle and I want a square of it. So I create a square of it, wrapping the circle. That's my intent. I declare my intent, and now take it and do something with this square. You want to do something, do it. You don't want to throw it away. It's a declaration. Imperative is like when you do the calculations, evaluations step by step, without looking into the future. So you do here and now. All calculations happen here and now. And that's resource ineffective. The code on the left will sometimes, this is just a simple example with this T. Of course, in a real code, you will see much more dangerous examples when you actually abuse the resource usage. There's a good question. The question is, the constructor works and calculates the S. What is the difference? Why I'm saying it's not calculated? Okay, that's a misunderstanding of what constructors are supposed to do. So you think that here, right here, when I do new square of, the calculation will happen in the constructor. No, it's not. The constructor will only take the circle, put it into a private attribute, and that's it. The actual calculation will happen when this operator is being called. So here, the definition of this class will be probably like this. Class, okay, it's a not real Java, but something like Java. Square of. The constructor, let's call it this way. The constructor accepts the circle, C. It says in the constructor we say this dot C equals to C. And then we say we have a method star, which accepts the float. And it returns return this dot C dot radius, blah, 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 blah. You understand? So that's the idea. So when you create an object, you only encapsulate. The constructor never does any evaluation. That's very important to note it, to mention it here. Constructors in object-oriented programming must only encapsulate what's provided, but never do any real work. Never do any calculations. All calculations, they happen in the methods, in the behavior. So the object exposed behavior through methods, not through constructor. Constructor is just a mechanism of encapsulating the state. Behavior is exposed only through methods. That's a very important principle to remember. Okay, a few more questions. What happens when we call S the second time? Is evaluation of S will happen the second time, or is it being cached? Good question. So definitely in the current design, if my class is designed like this, then every time we do multiplication, every time the calculation will happen. If we wanted to cache this calculation, if we wanted to store it, then we can do it like this. Float S, no, here we just stay. So we need to cache it. We need to, a short answer, we need some mechanism of caching. It could be a mechanism embedded into the language, so the language may provide you some mechanism, language itself, or it can be another object which you put around this square of and say, calculate me only once. For example, you make the object class calc only once, which encapsulates square of, and when you do star, then it calls the encapsulated square of, and what comes back, it stores in some, I don't know, some private attribute. So this mechanism of caching, you move it away from the real class. So this class doesn't know anything about caching. It's pure functional. So every time you call it, it does the calculation. That's more or less pure functional approach. So it doesn't cache, exactly, every time you call it, the effect is exactly the same. So it doesn't do any side effects, because caching actually is side effect. When you call it first time, it takes the CPU resources, it does the calculation. You call it second time, it doesn't use CPU resources. So this behavior is different, and that means the class is not really functional, it's not really pure functional. So it's better to have it like this. Yeah, so every time, it's the good question. So every time we need to cache, we need to make a decorator. In an ideal object-oriented world, yes, I believe this is how it should be. So every time you want to cache, you just move this, you just explicitly make this caching in another, for example, decorator. Yeah, in another decorator, or somehow you can do it maybe using annotations in Java, maybe using aspect-oriented programming. There are many, could be different approaches to this, but caching is separate from the functionality. It's a different behavior. One behavior is calculating the square of the circle. Another behavior is caching. Another question, isn't calling other class constructor considered coupling too? Or is it like in previous case, we can define it freely? Isn't calling other class constructor considering coupling too? Well, definitely it is coupling, definitely. So here, when we call new square off, then definitely we are coupled to this class, and this is unbreakable coupling. Again, unbreakable dependency. But that's a separate concern. So that's the concern from the previous slide. Here we can also discuss how to break this dependency and how to avoid this coupling here as well. The question is, again, another question. Constructor is by nature a static method. Constructor is indeed a static method. So actually constructors are like, in my opinion, they are synthetically created creatures, features in object-oriented programming, which actually do not belong there. So in a properly designed object-oriented language, we would not need constructors. We would just have, like in C++. In C++, you may have a constructor which just only encapsulate the provided value, so without the body. So you can skip the body. Well, you can put the empty body. In Java, you cannot do that. In Java, you need to really explicitly say, assign these to private attribute, assign that to private attribute. In C++, it's more elegant. So constructors are more like a feature of a language instead of really like a method, instead of really something which looks to programmers like a behavior. Because it's difficult for new programmers, for different programmers, even for quite mature programmers, to see the difference between static methods, methods and constructors. They think it's the same. They think that constructor is just something with a different name and being used a little bit differently. But they believe, like the questions before, they believe that they can they put some functionality into constructor. But you shouldn't. Constructors are only like a gates, like a door to the object. So they just let you encapsulate what's coming, and that's it. Stop it. No functionality there. Functionality happens later. So that's the point. Imperative, not declarative. So try to make it lazy, and that will help you get rid of static methods. And final point, which I said, low cohesion. So look at the class on the left. This is geometry utils. It has calculate square, calculate perimeter, calculate sinus, calculate cosinus, and many others. If you look at Apache utils, if you look at the many other utils, which we will discuss later today as well, there are sometimes hundreds of them, hundreds of static methods, which hardly belong to each other. So definitely there is some connectivity between them. There's some resemblance of the features they provide. So they are all definitely related to geometry somehow. But still, the larger the class becomes, the more it grows, the more tempting it is to put more function, more methods there. And this is what people do. You don't know where to put it, you put into utils class. Sometimes people even call it just utils. Not even geometry, not even file utils, no, but just utils. Just put it into utils. You don't know where to put it there. So cohesion just drops down, and then you get the class which is difficult to understand what it's for, difficult to debug, difficult to work with. So the code on the right is much better. So here we have the class circle, which knows how to calculate the square and the perimeter. We have the class angle, which knows how to calculate the sinus. And we can have class float, which knows how to calculate the cosinus. Here we have three classes. So of course, if you go for this design, you will have more classes. In this case, you will have less classes. And some people think it's a virtue to have less classes. So they say, why do we need so many classes? Cosine, okay, not sinus, but sine. Okay, my mistake, definitely typo. So they say that that's good to have the less classes. It's good to have just one large collection of methods. I don't think so. I think it's good to have more classes. In general, the more classes you have, the more objects you have, and the more cohesive they are, which means they have less methods, the better. So in my opinion, in general, if your object has more than 4 or more methods, okay, let's say 5, not to scare you too much. So if you have 5 or more methods, then it's bad. So this is not good. If you have 5 methods, 6 methods, 15 methods, it means that your class is not cohesive. It means that you are definitely having methods which do not belong to the same problem you're solving. You probably know about this single responsibility principle. That's one of the popular principles invented, I don't know, maybe 20 years ago. And this single responsibility principle says, it doesn't give the numbers, but it says that one thing, a module, a class, an object, a function, must do one thing, must be focused on solving only one problem, single responsibility. So it has to be responsible for solving only one problem in your code. So when you have this, then it's definitely not solving one problem in your code. It solves many problems. You help people calculate sine, cosine, and so on and so on and so forth. So you help solving many problems. On the right side, you solve your class, your object always solves only one problem. So try to keep them small. The more methods, the worse. 1 method, 2 methods, 3, perfect class. 5, not good. And static methods, they just provoke you to make low cohesion, because there is no limitation on that, because every static method is a completely separate creature. They're not connected. Usually they're not connected to each other. They're usually self-sustained, self-contained. So they contain everything which is necessary inside the method. If it's called square, then it does all the calculations, the parameters comes in, it does all the calculations and returns the result. It doesn't need other methods. It doesn't need this method. It doesn't need that method. It's completely good enough by itself. And that means that that will provoke you to make these utility classes, which are very low, extremely uncohesive. Okay, so these are the problems with static methods we just discussed. First, they are, I said, they're unbreakable dependencies. Number 2, they are eager and not lazy. And number 3, they they help you to create code which is not cohesive. Now let's take a look at attributes. We discussed methods, static methods. Now let's discuss attributes, also static attributes. So what they are for? I know mainly for 2 things. They're used for 2 things usually in the code. First thing is public literals. So we just define static attributes like constants. So it's a constant which is used from some other place of the code. So we don't want to repeat this number again over and over and over again everywhere. So we put it in one place in the code. And this is actually a recommended practice. So if you read about good design, read about best programming practices, then many authors will recommend you to do that. They will say, do it. So define constants. Why? Because they will tell you that if you put the number right where you use it, then it will be unclear what it is. So if you put 3, 15, blah, 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 all these numbers where you use it, then somebody else will ask tomorrow, like, what is this number? Let's say the person doesn't understand what is pi, so he doesn't know this number. And that person, that programmer, will look at the code and ask the question, why do you multiply by 3? And the most popular example which people give when they argue for these public literals, they say, let's say there's a constant in the code when let's say you have the code which looks like this, H equals to S multiplied by 3,600. So probably if you are smart enough, you will understand that probably this is the seconds and this is going to be the hours. And this is probably the number of seconds in 1 hour. But by just looking at this number, it's not really obvious that this is actually the number of seconds in an hour. So they say instead of using this, you just say hours, seconds, like in an hour, something like this. And then you put this somewhere and define this constant somewhere in the code with the proper name, with the proper definition. And sometimes the name of the constant is very long, like seconds in 1 hour. It could be a long name. I disagree with this approach. I think it's wrong. I think it only makes code worse, not better. Why is I think so? Because the main reason is that, again, looking at the code on the left, let's see what happens with this constant with locally. So I define it like fr. It's a funny example. Of course, it's not really exactly what happens in the real code, but still, something like this may happen, and it happens quite often. We'll see it a bit later. So look at the first 2 lines. So I say, you know what is this language like, right? I say s'il vous plaît. So in this s'il vous plaît, I use this as a locale for println. So println needs the locale in order to print the text to console. Here in the second example, I'm a programmer, let's say I'm a programmer, so one programmer writes this, another programmer writes this. So the second programmer, this is the first one, the second programmer just takes this constant and use it differently. It doesn't use it like a locale, but it uses it like fr, like 2 letters. So it puts it in a different context. It uses the same public literal, but in a different context. Because nobody can stop him from doing that. Because it's just a bare data, just string. So there is no behavior attached to this string. It's a completely so-called naked data. So just the data publicly exposed to everybody. It's just the data sitting in a public scope and saying, please touch me, please use me. And of course, everybody will try to use that data. To use in different, not always the right way. So that was an abusive way of using the data. The data was not intended to be used this way. Because this data is actually a locale. It's something about France. It's not about 2 English letters, fr, which is used now in a word free. But the user, the programmer number 2, didn't understand that. He didn't care about that. He just said, okay, it's a publicly available data. I exactly need 2 letters, fr, so let me take that data. So there is no behavior attached to the data. They are exposed to everywhere. And that's a problem. That's what happens when we do these public literals. We just expose the data without attaching the behavior to them. So it would be much better if we design it differently, like in this example. So we design like we have 2 classes, the print, the text and the French, and then we use the class print and encapsulate the text in French. So this text in French inside this class text in French, somewhere inside will be the necessary locale used inside. But it will be used inside there, so there will be functionality around it. So there will be behavior around this data. It's not anymore a naked data. First of all, nobody can see this data anymore. So in this example, we don't see the fr. We just see the name of the class, French. So now we know what we're talking about. We're talking about French text. Not 2 letters fr and who knows what it means, locale, whatever. But we know exactly this is text in French. So we make much more context aware. The data become much more context aware. So every time you make the literal public like this, you definitely, not definitely, but you think that you solve this problem with the number, with the pure number. But I think you introduce a bigger problem. You just invite people to come and use my data. when they get attached to this data, many of them, then you touch this data in order to solve, in order to, to do something for one of the clients who are attached to this data from different parts of the from different places of your program. And then you satisfy one of them, but others will not become happy. So let's say we change this FR at some point of time to FR_BE. That's another locale, which is the Belgium. So we change it because we decide, okay, we need to be more specific. And this code will work even better because it's going to be more happy because of our locale changes. But this one will break. And if we don't have proper unit tests, boom, we have a really strange, weird mistake, which will be extremely difficult to trace. Understand? So let me read your questions. You have them. But what if we use not an obvious constant in many places and maybe it can be changed in the future? What if we use not obvious constant in many places and maybe it can be changed in the future? Yeah, that's exactly what I'm saying. So if we use this constant in many places in the code, we link to this constant from many places of the code, everything will be fine as long as we don't change the constant, as long as we don't change the data. But when we change the data, all of these guys, or some of them, will break. Not all. If all of them, it's good, because then we're probably going to catch that in the unit test. But what if some of them will break, but others will not, because they made different assumptions about the data. So these two pieces of code, this one and this one, they made different assumptions about the data. The first one assumed that this is something related to French, and this locale related to French, so the user didn't care about FR, or it doesn't matter. It didn't matter for the user what is the value of the constant. That what mattered is what it's for. The second user actually cared about the letters FR. So he made an assumption that now this constant is actually just two English letters. And this assumption was, they both were correct for time being. But when the constant changed, one of the assumptions just became invalid. And that led to runtime error. Another question, what about class level private static constants? Is it okay to use locale only inside the class? Yeah, that's a good question. So what if we replace this word public with the word private? Then I would say it's a smaller problem. Definitely we make the scope of the problem smaller, but still it's inside the class. So what's the point? And what's more interesting, if you do it this way, you have the constant inside the class, which is private, but then later you will need something similar in another class. And then you will define, for example, let's say you define pi, this constant, here in this class constant. And then you need it somewhere else for another calculations. Then you will define it elsewhere as well. So you have it in two places in your code. What if tomorrow somebody comes to you and say, you know what, I don't like the precision you use right now when you multiply by pi. You need more digits after the dot. Then you need to somehow go through entire code base and find all the places where the pi is mentioned. And if you're lucky, you're going to find all of them, but most probably you're going to miss some of them. So instead of doing that, just think what this constant is for. It is a relationship between the diameter of the circle and the perimeter of the circle. So make a class for it, which encapsulates this functionality, this behavior. And every time you need to multiply by pi, go to this class and ask this class to do it for you. So never mention pi. Every time call this class, which you call, I don't know, a pi. Call it a pi, or call it a circle, a relationship on the circle. Something like that. So naked data is wrong. If the data stays without the functionality, either privately or publicly, you're begging for trouble. Next question. So in this case, we should have main interface for each text in, for argument to constructor class. Yes, exactly. So definitely in the right example, which you see on the right side of the screen, you will need more classes, more objects. Text in French, text in English, text in German, text in Japanese. So definitely you need, or you need to think about how to design them so that to minimize the number of classes. But definitely this will require less classes. Everything I teach you on this course will definitely lead to more classes, to more objects. It's inevitable. If you want less objects, then you're moving down to procedural programming. So then you move down to C language, to Algol language, to Fortran language. They have 0 objects. If we move to Java, if you move to C++, Python, and object-oriented languages, then we need to make objects. And the more we have them, if we design them properly, the better. So just get ready for that. Objects is something we will have. Classes, objects, and each class will be small. So there will be many small classes, small objects. That's just a side effect. Or actually, in my opinion, this is good. But some people who come to this, who start practicing this, they think it's bad. They feel like the program becomes more verbose. So you write more, you type more characters, you make more scaffolding of your code, preparation, putting things around. Before you actually write the multiplication of 5 by 5, you need to create a class, and then you create a method, then you create an attribute, then you create a constructor, and only then you do 5 by 5. And then they ask, why I need to do all of this if I can just write one line and say 5 by 5? Well, the ultimate goal is to make the program more maintainable. Because one line 5 by 5 is easy to understand as long as it's one line, as long as you have nothing around. But when your program starts growing and you have 1 line, 2 lines, and then 500 lines, and then 10,000 lines, then it will be beneficial to see these lines being grouped, being aggregated in proper pieces. And these proper pieces are objects. Or functions, if you do functional programming. Actually, there's another approach which is called functional programming, also very, very powerful and also very, very good if you do it right. But you're gonna have many functions. I teach you now object-oriented programming. You have many objects. In my opinion, it's even better than functional programming. Why? We can discuss maybe at the end of the course. Again, another question. As I understand, we operate with the behavior, calling a function which uses the constant inside locally, and nobody knows it, as nobody knows the implementation. Exactly. Every time we try to encapsulate the data into the object and expose the behavior. Remember the first lecture. Hide the data, expose behavior. So nobody knows what is the value of pi. Nobody in your code. Only one piece, only one place, which encapsulates this pi and expose behavior. You want to multiply by pi? Come to me. Give me the number, I'll multiply by pi, return your result. But I'm not going to tell you what is pi. I'm not going to tell you the value. I can multiply. I can make a square of it. I don't know. I can divide by it. I can do whatever you want, but I'm not going to tell you the number. Hide the data, expose the behavior. Okay, and the last one for the theory is singletons. Probably you know what are singletons. Look at the code on the left. This guy is a singleton. So singleton is a design pattern. For those of you who don't know, it's an object which we want to exist only in one instance. Well, it's a class which we want only to exist in one instance. It's a class which we want to have only one instance. That's the proper definition of a singleton. So in Java, any class it may have multiple instances. So I can say new, I can use operator new, and from any class I will get an instance. Any class. But in Java, they invented this mechanism. I think it's an invention of Java, to my knowledge. So they said, how about we make a private constructor? A private constructor. So now it's not possible to say new canvas. So this code will not compile. The compiler will say, no, it's not possible because the constructor is private. But you can look at this code here. This is exactly what I told you just now, that it's not possible. It is possible only here. So according to Java rules, according to Java grammar and syntax and grammar, then it's possible to do new even if the method is private, but inside the class, new is allowed. So what they do, they say, here's the public static, you see, we're talking about static, public static instance, and this instance is assigned to new canvas. So when the program starts, when the program is compiled, then the virtual machine starts. The virtual machine, before executing any of your code, it executes this. It runs this command, new canvas. And then it goes into the constructor. Constructor is usually empty. So there is nothing happens in the constructor. It just makes an object, puts an object into memory, and object stays in memory. Every time somebody needs this object, they go like this. They say canvas, instance, add circle. So it's a public static reference to an object which exists only once. That's how singleton works. Okay, so you're saying that you already know 22 design patterns. That's good. So you know what is singleton. So I just wasted 3 minutes of your time, but still good to. Okay, if you know about singleton, so let me ask you a question, which you supposed to be able to answer since you learned the design patterns. So tell me. Well, first question is usually this design of a singleton is not how people do it. So usually they make this constant, this statically literal private. So instead of public, they say private here. And they introduce another method. And the method is called public static get instance. Get instance. But even if without this get instance, maybe I even made the question more difficult than it should be. So tell me, what's the point of making a singleton? What's the point of all this hassle if we can, instead of all this, just use a utility class? So look at this. Add circle will take the circle and add probably to some private attribute. But I can make this attribute static as well. And then this method will be also static, the add circle. And it will be a singleton. So why people introduced a singleton? Thread safety, they say. But thread safety I can enable as well using just utility class. I can make utility class thread safe. Every method will be thread safe, and that's it. They say they didn't explain us. Okay, to remember the state and modify it. I can remember the state using static attributes. All the state of the utility class may have a state. I mean, static state. So I can define the state using static attributes. So I will have static attributes, static methods, and I will call this a singleton. I mean, it will exactly work like a singleton, one-on-one. So the question is, why people invented singletons? That's right. Vladislav is right. To mock it in the tests. So the only benefit a singleton has comparing to a utility class is the ability to be mocked, to be replaced in a singleton. Remember, static methods are unbreakable dependencies. Singleton is a breakable dependency. How? We can assign to this variable during the testing, assign a different object. So now it's this one. But while I'm doing testing, when I do testing, I can assign something else there, and my tests will they will think that they work with my singleton, with the canvas, but something else will be assigned to it. With the utility class, we cannot do that. So that's the only purpose of a singleton. So that's a good, you understand it well. So look at the code here. So I understand that singletons, again, is a bad idea because it's static, because it's globally available, and because for the same reason with the data. So there will be many clients connecting to the same place. And when we decide to change the behavior of this place, with the data, remember, I was telling you that if we decide to change the behavior, to change the value of the data, of the naked data, of the data exposed to everybody, we change the value, then some of the clients will break. Some of the clients will stop working because they didn't expect that. The same here with the singleton. So if I change the behavior of this singleton, if I don't know, change the not here is not the behavior. The problem with singleton is that we are, well, it's unbreakable dependency. Let's scratch my previous argument. It's unbreakable dependency. So everybody will be connected to the singleton. They will use the singleton, and it will be difficult. It will be harder. It will be possible because it's a singleton, not a static method, so it's easier to break. But still, it will be much more comfortable if the code would look like this. And everywhere the canvas is required, it will be either created or passed as an argument. So let's say we have a function paint, for example, like this, paint. And I pass the argument as a canvas. Sorry. So I pass canvas here, and I do inside the function, I do canvas, add, whatever. So this is my function. Now, instead of using the argument, I refer to the instance of the singleton. And that, of course, is a dependency which looks ugly in my opinion. So this method suddenly, I call the method, and the method suddenly just knows too much and says, hey, I'm going to go to another place of a program and touch it there because I remember that something important is there. But the caller of this class was not expecting this to happen. The caller expects the client, I'm saying the caller, the client coming from there expects this function to be self-sufficient, having no side effect, and not talking to somebody who is far away from the function. So it's better overall summary of that. It's better to make this canvas and pass it everywhere where it needs to be. So just use it as an object, and everywhere you expect another function or method to use it, just give it to it. Just go everywhere in the program with this instance and pass it there and put it there, put it there, put it there. Let it use this object when it's necessary, but not go. Actually, it's also a violation of quite a fundamental principle of layered architecture. So we know that if the client is coming to a function, if I call somebody, then I expect this somebody to make only calls downwards. So they will call to smaller, like we discussed, the abstraction. So there's a larger abstraction, and then I call this abstraction, and I expect this abstraction to go into smaller abstractions. But in this case, I call paint, and then all of a sudden it goes up. It goes upward to the larger abstraction, some global thing, and talk to this global thing. So this upward directed connection is basically, we're again begging for trouble. Let me read your questions. I have so many of them today. So how then should we handle database connections if we don't want to open it again and again in different parts of the code? Well, the answer is yes, pass it. Exactly, the answer is posted there by Vladislav, that pass a single object as a dependency, of course. So every time you have a place in your code which needs a database connection, just say, I need a database connection. That's a parameter for me. And then who's going to call you, it's going to be their concern how to prepare this parameter. And then if it's a larger function, again say, I need this parameter. If it's a larger function, say again, I need this parameter. So in the end, it's going to be your smaller object needs database connection, a larger one needs database connection, a larger one, and then in the end, the largest one will need database connection. You will create this database connection and pass it through all of them, through this Russian doll of objects, objects and objects and objects, and the connection will fly. Of course, it means that you will have more parameters in your functions. And people complain about that. They say, we don't want 50 different parameters to come into my function. That's why my function is going somewhere. Sometimes they don't even make singletons, they make they make dependency injection containers. And these containers are just large singletons with different objects inside. This, in my opinion, is a super ugly design. The ugliest. These dependency injection containers, DI. So DI is a good idea. Dependency injection is good. Dependency injection is when I'm expecting the dependency and you inject it to me. So I need a database connection, so I say give it to me as a parameter. You give it to me, I use it. That's dependency injection. Well, it's dependency, it's providing dependency, not dependency injection. Injection is more like I don't know what's going on, and then boom, from somewhere outside they inject into me, into my body, so I'm an object, and they inject into one of my attributes, they inject the dependency. So when I start working, it's not coming to me through the constructor, it's just here. So one of the attributes were assigned to the dependency. So usually they do it through the annotation. So in Java, for example, you can say like this, annotation, and say dependency, and then this is my attribute, private, for example, database, and then, for example, I don't know, D. So this is my attribute with the type DB, and then I started, it's not coming from the constructor, it's not coming through anywhere, it just magically behind the scene, it's just there. I just expect it to be there. So dependency injections, yeah, the DI containers is a bad idea. Vladislav is sending a link to some video. So, and this, in my opinion, that's a completely wrong idea, not even worth discussing that. So this dependency injection is a broken concept. So you have to make your classes, make your objects, make your classes the way that they accept dependencies only through the constructor. The constructor expects, sometimes you will have many attributes, many elements in the constructor. So the constructor will be bloated, it will be large. It will expect like database connection, the canvas, the file system, the connection to the network, maybe connection to another database, so like 1, 2, 3, 4, 5. It only means one thing, that you violate the single responsibility principle. Your object needs too much. Your object expects too much. Your object does too much. That's why it needs so many dependencies. In normal situation, it shouldn't happen. It should be just 2, 3, maybe 4 maximum dependencies which your object depend on. But usually it's 1 or 2. If you have more, then it's a wrong design. So the comment is, behind the scene it's a setter. Isn't it the topic of the future lectures? Yes, definitely. Behind the scene, the setter is happening here. So this guy is being injected usually through the setter or the implicit setter. So they don't you don't declare the setter, but they have the magic engine which just injects it there using reflection. For example, in Java, there's reflection API, we just cross-cut through all the encapsulation abstraction principles and just inject something into you. That's a completely abusive and hurtful behavior towards an object, as far as I understand object-oriented programming. Okay, so now we have how much time we have? I think we have 10 more minutes, or no, sorry, we have 10 more minutes, that's right. Let me read another question. Top-level object can have many dependencies, isn't it? Yes, definitely. Again, Vladislav is right. The higher the level of the object, the larger, the more it covers, the larger its abstraction it is. The larger the abstraction, the more dependencies it definitely will have. Of course, if it's a small abstraction, if we just abstract a small, connection to the database and reading the data from it, then definitely we can provide only one dependency and that will be it. But if it's a larger abstraction, let's say it's an abstraction of the entire 3D painting system, then maybe it needs more dependencies. But we will talk about this a few more lectures further down the road. How to make it, how to get rid of the large constructors, because having too big constructors and too many private attributes, it's not a good idea as well. It's not going to look, the code will not look elegant in this case. Yeah, okay, so I'm basically done with this provocative discussion. So now let's take a look at this is called FastJson. I just found it randomly. Just I googled the most popular Java projects and I found FastJson. It's created by Alibaba company. It has about 10,000 stars, or like a lot of GitHub stars. So it is supposed to be good Java code. Let's see how they use static methods. I just found a number of examples. No, let's start from utils. Something, 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 utils. So they make utils. In these utils, they have, as we discussed, they have everything. They have final static attributes like this, for example. Field, name, args, type. How on earth I'm supposed to understand what does it mean? Archetypes. I don't know. There's no functionality attached. So my bet is that I can use it as a data. Remember the example with locale. The locale was more or less understandable what it is. Here, nobody knows. Well, if I really understand this code, then I will probably understand that no, I cannot use it as just a piece of text. It means something that somehow connected to, let's see what is connected for. It is connected to here. So look how they use it. They call some lexer and they provide some. So what's the point of using, look, they use it twice, here and there. Instead, it would be much better to do it like this. Final string, whatever. Define it here. What's the point of moving it up? Define the string where it is being used. Even this will be better. But placing it like this is just inviting me to use it for something else. They just tell me, hey, it's public, it's for you, use it. So that's wrong, definitely. Another example, look, this is a codec, this is singleton, look. Public class long codec, so this is some codec, and then public static long codec index no long codec. That's a singleton made by people who don't understand how singleton works. Because if you do it this way, then where is this? Look, even the Copilot understands it. So there has to be this code as well. Because without this private constructor, the singleton doesn't make any sense. Because you make it this way, and then I can make another one. So if you don't protect, if you don't close the possibility to make new objects, then you just misunderstand the idea of singletons. Okay? That's just funny example. So it seems like the guys are not understanding. And why this is low case, I don't know, because in Java it has to be like this. And look, I named it instance. Oh, it's not used anywhere. Look, it's unused. So, so this line can be completely deleted and nothing will change in the code. All right, so maybe it's for some public users. So that the user is supposed to find out that this stuff exists, and the user will say, okay, I'm not gonna call that, so I'm gonna use the existing instance. Maybe I renamed and new name is not used. Okay, my mistake. Yeah, sorry. That's right. There you go. It is used. Sorry. Okay, so it is used in some places, here. You see there is some usage there, but again, it's not a properly designed singleton. Here, it's another funny piece of code. Look, another singleton. So they have public static, blah, blah, blah. Then they have public constructor. So again, probably this guy, well, he understood singleton a little bit better, but not completely enough. So that should be like this. Because otherwise, what's the point of making public constructor empty? Because this is the default constructor, you can easily remove that. It will work exactly the same. So probably he intended to make it private, but didn't do it how it should be. Okay. Another example with for example, this. So they make a codec. So it's a string codec. So it's supposed to code something, right? So we have like public method write, public method write, public method deserialize, and then public static method deserialize. So that's a complete mystery to me. So why making deserialize into the codec, which accepts exactly the same parameter? Look, there's a parser coming here, and there's a parser coming there. Oh, there's some other parameters, and this doesn't have the parameters. I hardly understand what it's for and why they made it static. So I'm going to read your comments. Maybe you know. Yeah, that's the same guy, the same author. Yeah, the same author made that. The same Wen Shao. So this Wen Shao guy somehow implemented deserialize. So now when we call this deserialize, we're supposed to it's kind of strange why making this publicly available when we have a codec. So for codec, it's logical that if you have a codec, then you make an instance of this codec, and then you deal with it, you call write, whatever, deserialize, I don't know what it does, but that's just weird design. Let's see something more funny. Okay, here, factory. In the factory, they use, oh yeah, this is interesting. So look, this is the factory, which is supposed to, maybe it's the same guy. No, it's different people. Oh yeah, Wen Shao, he also participates here. So there are two methods. Look at these two methods, create. So they are, instead of, so look, this factory has a constructor, then the factory has another constructor, and then for some reason they created another method, which is called the factory method, which I'm also against. So I also believe that that factory methods are a bad idea because they're static methods. So for some reason they created a static method which calls another static method, and this one basically does the validation of the incoming parameter. So they take, so basically they do, and then they call this the constructor, this one. So basically they validate this for null, and here they don't validate for null. I don't know what kind of magic it's doing. I mean, how the user is supposed to understand that? How the user will understand what to call, the create, or this one, or this one. It's pretty weird. But in general, making static methods is static methods for as a factory methods, I think it's again a wrong idea because it well, it was invented. The factory method was invented for this, so it should be done like this: public static. What's this? But it should be for the interface. It cannot be for the class. So this class is, I don't know what it extends, but yeah, it extends this. So in this case, maybe you can do this, like this. And then you pass something as an input and say, I don't know, string base URL, for example, yeah. And then here you say, if base URL equals to null, then you, not throw, but then you return one instance, like this. Else, you return something else. Yeah, but they don't have it. They don't have anything else, but they're supposed to have a different implementation of the same class. I don't know. Like this. So you have, in one case you return something, in another case you return something else. So this cannot be implemented using a constructor. This is not possible to implement if you have a constructor. Because the constructor, when you call the constructor, you already know what class you construct. It's too late to make a decision whether you need this class or you need this class. So this decision is already made. You already call from your code, you already say, somewhere here you say new this. So it's too late to make any other decisions. But if you say this, factory, then of course this method, because this is the static class, So it's just a globally available procedure. It's not really, it doesn't even belong to this class. It's just a namespace for the method. So when you call this, then yes, at this point of time, it may return this class, or it may return blah blah. So the decision will be made by the factory method. It does make sense initially, but I believe that if you go down this road, if you start designing your code like this, then these decisions which will be made in runtime of which instance of which type to create, it may, I even wrote a blog post about it a few years ago, and the main reason is it will take too much time to explain it now, but just go to my blog and type in factory methods. You will see the paper, you will see the article which explains why the factory methods are a bad idea. But they are bad for this discussion, for this lecture, is enough to say that they are bad because they are static methods. And we discussed the problems with static methods before. But in this case, these guys are making something really funny because they exactly doing the same what the constructor is doing, and they're just introducing some new functionality which some magically unclear to the user for some reason exists here but doesn't exist here. Yeah, and of course they do it wrong over there, so they're not supposed to design like this. Probably you understand this. They should do like this. So when you have, that's another topic maybe, but just good to mention. So this, I would say, a primary constructor, primary entry point, and this is, let's see what, it doesn't understand. So this is like a, secondary entry point. Primary constructor, secondary. So you may have many secondary entry points, for example, like this, and all of them should call, for example, here you have the string, here you have the float, and all of them call the primary entry point, or they call another secondary entry point. So you must have only one primary constructor, only one constructor which accepts what needs to be encapsulated. Here it is. It accepts and encapsulates, and then all the primary entry points, all the secondary entry points, they call either each other or the primary one. But you never ever do this. You never do this, because if you do this, we have two primary entry points, the first one, the second one, and that creates confusion. That creates a lot of confusion for your future design. So you have, again, only one primary entry point which does the actual assignment of the coming parameters. Okay, guys, I see you having fun in the comments discussing my blog. Yeah. All right. So let's continue. This code. It's not fun. Okay, so you're discussing something serious. Okay, let me read it. Let me read the question. There's a comment, really it's weird here, probably referring to the previous one. It's weird here why we have a static function and a constructor at the same time doing the same. Yeah, it's weird. And then the question in the beginning about repeating the question about extending functionality of an existing type. Let's say I want to use string class, but with some extra functionality. How to do it better without creating string utils? That's a very typical question. So yes, you have a string class which has some functionality, but you want some extra function to be added to the string. Java is not very object-oriented language, and it doesn't have, well, let's put it this way. Maybe Java is an object-oriented language, but JDK, the runtime library, the standard library of Java, is not object-oriented. Because, for example, string cannot be, it's a final class. So you cannot extend string because it's a final class. But in an ideal world, the design in Java should be this way. In an ideal Java, it should be interface string with some functions here, for example, function trim, function lowercase, function, I don't know, something else, some other functions, like substring, and we will have class, I don't know, basic string, which implements string. That would be Java. And then if you want to extend it, you say, you see, Copilot understands it. So you say class extended string, and then you extend basic string, something like this. And you have user case. And finally, you do string, new extended string, like this. Or maybe even like this. Decorate the basic string. And then you do s dot uppercase. That's ideal Java, but you cannot do it because string is a final class. So in the proper object-oriented language, it should be like I just explained to you. What to do in Java? Let's ask the question. How do we do it in Java? Because we live in Java and we want Java. In this case, we, like somebody already mentioned, that you may create something like an extension of a string, which will be some sort of a, an intermediate, like not a perfect implementation. So you say class, for example, text, you call it a text, and then you do, which encapsulates, you see, Copilot is smarter than me. So it encapsulates the string, and then you do, uppercase, whatever. Yeah, that's exactly this. So then you, instead of doing string utils uppercase, instead of doing this, you do this. No, you understand me, right? Yeah. So you encapsulate in the string. That is better than this, and it's slower, and this is faster. So again, think about what you need. You need a faster code, or you need more readable code, because this is more, in my opinion, more readable. You can do much more if you design it this way, but the speed will be higher this way, unfortunately. There is a language support in C# for extending existing classes. You see, so maybe C# is better than Java in this particular case. Maybe one more example. Again, look at this class. It's funny. You see, private static literal, which has absolutely no sense to me. I don't know what it is. So again, it's a naked data telling everybody just use me for any reason you want. And then they have a huge static class to string. It's kind of weird, because it kind of, the class says it's a double. So it means that an implementation of Rue for double. So why toString is all of a sudden static? So it seems that this method doesn't belong here, this method. It's just toString, which absolutely has nothing to do with this class. So why it stays here? It takes the double and convert the double to string. What it has to do with the Rue, with this? Absolutely nothing. So this guy who implemented this, he just like, whatever, where do I put it? Just anywhere, just give me the place, give me the just empty lines of code, so I put my code there, because it has absolutely no relations to this Rue class. Or maybe, okay, it calls this one, but again, yeah, it calls this one, so maybe I'm wrong, but again, this one also static, so it gets everything it needs from here. Or maybe it is connected to this. So it's messy. It's difficult to read that stuff, difficult to understand what the cohesion is not clear. So I cannot really see that these things belong to each other. It just randomly placed, or maybe not randomly, so it's not clear to me. The intent of the programmer is not obvious. Because the classes in object-oriented programming, or objects, are supposed to be abstractions of certain things, like we discussed on the first lecture. Abstractions of certain things. So what exactly is this an abstraction about? Of an implementation of Rue for double. Anyway,